Welcome viewers here to another episode of Science. I'm your host, Teacher Isaac. Today we want to look at reflection of light. Reflection of light, we shall start by defining it. So how do we define reflection of light? Reflection of light is the bouncing back of light rays. In other words, when light hits a surface and bounces back, that's what we call reflection. In other words, it's being sent back. Okay? Alright. I have a diagram here I have to explain. It has rays, two rays, this and this. We have the one in the middle. So this is A, we have C, we have B. We have angles I and R. So let's start with this ray. The ray which is striking the plane mirror. This is our plane mirror here. It can also be a reflecting surface, okay? So the ray which strikes the mirror or the plane mirror is what we call the incident ray, okay? The incident ray strikes the mirror. Now, that which bounces off the mirror is what we call the reflected ray, okay? So we have A as incident ray, then we have B as the reflected ray, okay? Now, we have C here. C is what we call the normal ray. Why is it normal? Because it is perpendicular to the reflecting surface or the plane mirror. That sign you know very well represents a perpendicular. A perpendicular means something is touching the surface at 90 degrees. Okay? So that ray which strikes the mirror at 90 degrees is what we call the normal ray. You can simply call it the normal. Okay. Now we have these two angles here. We have angle I and angle R. Angle I simply means the angle of incidence. The angle of incidence is that angle between the incident ray and the normal. So the angle between the incident ray and the normal is called the angle of incidence. Don't forget this is incidence, not incident. Okay? That word there. Incidence. So the angle of incidence is denoted with that letter I, small I. Then you have R, small r, is the angle of reflection. Now what's the angle of reflection? That is the angle between the reflected ray and the normal ray. So between the normal ray and the reflected ray, we have an angle. That is what we call the angle of reflection. Okay? So basically, or majorly, those are the 5 things we need to know about this. Number 2, in order for reflection to take place, the best way to get a smooth reflection should be on a smooth or shiny surface, as we shall see. So other objects can reflect, apart from the plane mirrors. We have the walls, especially white walls, okay? Those that are painted with white can reflect light. They always ask you why a room would be painted white. It is painted white not to reflect heat, but to reflect light. When light falls onto the walls, it is reflected back into the room. Then you will have sufficient light, though you may have a small bulb, but the light will be sufficient. That means the walls have helped you to send back this light being sent by the bulb, or the light bulb. Let's look at the types of reflection. Types of reflection are 3. The types are 3. We have the regular reflection, we have the irregular reflection, and the normal reflection. Now, what should a regular reflection look like? I already have a diagram here. I shall turn over to this diagram. A regular reflection, the examiner tells you it occurs on a shining surface and it has to be smooth, okay? Occurs on shining and smooth surfaces. So this represents a smooth or shiny surface, okay? Now that kind of surface will give us what we call a regular reflection. In other words, the rays of light are regularly reflected, okay? They are in irregular patterns. They are not diffuse or disorganized, okay? They are irregular patterns, the way you see far. The angles will be equal. All angles will be equal. Either incident or the angle of reflection. They have to be equal for a regular reflection. Where does it occur? They'll ask you if you have a shiny wall, if you have a blade mirror, even if a glass which is coated, of course, on one side, of course, because if it's not, light will go through, it won't be reflected. You have these small combs. Normally I call them scratchers. I don't know where the word came from, but they are used for combing. Eh? They have that mirror. So you can use it. Some of you play with it, you make it face the sun, then you see some light being sent somewhere else. That is reflection from the sun. So I'll take you back to the moon, where we said it is a non-luminous object. And remember, we said it reflects light that is produced from the sun. So it does not produce its own light. Now, a moon works exactly like a plane mirror. When light comes and falls onto it, it sends it to us. Then we think a moon is producing light. No. It is not a luminous object, it is a non-luminous object. So basically that is regular reflection. Let's look at irregular reflection. When does irregular reflection occur? This one has to be a rough surface, okay? This one is a rough surface. Another name for this type of reflection is diffuse. We call it a diffuse type of reflection. Why? When you look at these rays, they are scattered in different directions. They are not uniform, okay? So basically, this one is what we call an irregular reflection. Where does it occur? Especially on rough surfaces, not shining, the opposite of the other one, definitely. So, rough surfaces will produce irregular patterns that constitute an irregular reflection, type of reflection. All right, those are the three. I'll take you back. We started with the regular reflection, where everything is just uniform. The rays are reflected uniformly. Then we came to the irregular reflection, where the surfaces are rough. It happens on rough surfaces. The last one is right here, the normal reflection. Now, I've written for your statement here with normal reflection. A ray traveling along the normal is reflected back along itself. Now, what does that mean? When light comes through the normal line, it is reflected back through that path, the very path it has come through. Okay? That is where the normal reflection will be observed. Okay? It comes, strikes the mirror at 90 degrees. It has to be sent or reflected back at 90 degrees still. Okay? So in other words, you are free even to put a right angle here. Okay? For perpendicular lines, we always put a right angle just to mean that there is 90 degrees between the two lines. The normal, the horizontal and the vertical line. Okay? Between those two, we have a deviation of 90 degrees. All right. That brings us to laws of reflection of light. What are some of the laws that really light follows? We look at the first law, the incident ray, the reflected ray, and the normal all lie in the same plane. That occurs at a point of incidence, where all this, where the incident ray hits or strikes the mirror. That's the point of incidence. Now, at that point, all of these lie in the same plane. Okay? So, remember on our first diagram, we looked at the reflected ray, the normal ray, and then the incident ray. Now, those three lie in the same plane. Then this one is very important. Always remember that the angle of incidence is equal to the angle of reflection. In other words, angle I is always equal to angle R. That is a law. It is like a rule, okay, or a principle. It's no longer a hypothesis. It's now a principle because it has been proven, okay? Now, I want us to to try some numbers here. I'll represent one of these as angle, let's say 30. If I told you have this at 30 degrees, okay? It is very simple. If that's 30 degrees, we have said I is equal to R, okay? I is equal to R. That means even R is 30 degrees. In this case, you don't have to calculate. You don't need to look for your calculator, look for, scratch your head, no way. Because these are the same. The law states that the angle of incidence is always equal to the angle of reflection. Let's look at a situation where you have to calculate, okay? This is where you have to calculate. Given a glancing angle, the angle between the incident ray and maybe the reflecting surface. For example, they can tell you, given this as 60 degrees, calculate angle I. Calculate angle I. This is very simple. What you tell the examiner is that from the second law, the angle of incidence is equal to the angle of reflection. Always remember that law, because it is the one that will help you to calculate this. Now, let's look at these two. When you add this plus this, you have to come up with 90 degrees. Don't forget that, because it is a perpendicular, okay? Let's just look at this side. Let's leave around R, okay? Now, you say that angle I, that is the angle of incidence, plus 60 degrees will equal to 90 degrees. As simple as that. Yes, even if you are from sleep, you can find angle I here. Even if you are from sleep. Okay? So let's try to collect the like terms. Angle I plus 60 degrees minus 60 degrees is equal to 90 degrees minus 60 degrees. Okay? We are trying to collect the like terms. We have to subtract 60 from both sides. So in this case, we have I plus, of course, 60 minus 60 will give us a 0. That will equal to 90 minus 60. I know you know that. But if you can't do it, you are advised to do side work, though that would be not for a P7 child to do this. Okay? But if you want, you can say, this is my side work. Then you subtract 90 minus 60 degrees. Okay? So 0 minus 0, you get a 0. What of 9 take away 6? Think about that. What do you get? Do you get 3? Do you get 1? Do you get 4? Okay? 9 take away 6. So we shall have a 3 here. So that gives us 30 degrees. Those who can subtract directly, you can always use side work. Therefore, I have I equaling to 30 degrees. As simple as that. They can still give you the same, the way you see it, and ask you to calculate the angle of reflection. How will you calculate the angle of reflection? You need to start with the angle of incidence. After getting the angle of incidence, what will you tell the examiner? You tell the examiner, but angle I is equal to angle R from the laws of reflection. And simply, you will just write that angle I, therefore, is equal to 30 degrees. Let's try such a number, and that will be the end of calculating such angles or such problems. Okay? Given I have a plane surface, okay, and ray is striking. They'll tell you this is angle maybe 40 degrees. Something comes like that. One, they'll tell you to complete the diagram. Complete the diagram. How do you complete the diagram? You need to put the reflected ray. And it doesn't come on one side all the time. Sometimes you find a diagram drawn, having the angle, the reflected ray coming from the other side. Okay? So don't say, the teacher told us this one doesn't exist. It can come from any side. Light can travel in all directions, you know that from the characteristics of light. How shall we complete the diagram? We shall complete the diagram by putting, first of all, a normal. The normal has to be dotted. Okay? That one forms a perpendicular with the reflecting surface. Then you have the reflected ray. Now, what are you supposed to note? These arrows don't meet. They are not supposed to meet. Okay? So this follows the other, like that. Some of you, when I told to complete the diagram, you make arrows face each other. That is wrong, and you cannot pass that. All right. Now, calculate the angle of reflection from the figure above. Calculate the angle of reflection from the figure above. All right, let's try to find out what angle R is. Definitely, angle R they are talking about is just here. Being talked about in the question is there. So let's see how we can find angle R. Definitely we shall say, if this is angle I, okay, you can evaluate. So let's find angle I first of all. So calculating angle of incidence. Calculating angle of incidence first, because you cannot find angle of reflection without first of all getting the angle of incidence. Okay? We know that if I get 40 degrees plus I, that one should give me 90 degrees. So you can rearrange this. You say I plus 40 degrees is equal to 90 degrees. Okay? In the same way, we shall collect like terms. We shall have I plus 40 degrees minus 40 degrees is equal to 90 degrees minus 40 degrees. Okay? As simple as that. What do we have? I plus 40 take away 40 is 0, is equal to 90 take away 40, that gives us 50. But if you can't do that, please, I advise, use side work. Always use side work in order to come up with the right answer. Okay? So in other words, I alone is equal to 50 degrees. As simple as that. But that's not the answer. They told us to find the angle of reflection. Our question states we need to find the angle of reflection. But so far we've seen the angle of incidence. So we shall tell the examiner, but, just write it there. But the angle of incidence is equal to the angle of reflection. As simple as that. The moment you state that, a person who is a physicist will just know what you're talking about. That, oh, now the answer is got. Therefore, you are free to use those dots. We allow them. Therefore, the angle of reflection is equal to 50 degrees. As simple as that. Okay? No one will ask you why have you got 50. This explains it all. The but explains it all, that angle I is equal to angle R, okay? So basically, that is what we wanted to see today. Thank you, you've been good listeners, good viewers. I wish you all the best for now. Please stay safe and follow the SOPs. I remain yours, Teacher Isaac. Remember to subscribe to our YouTube channel so that you can get all the videos that we keep uploading. Have a nice day.